the entire universe will be aware of this one explosion. It's a star that is on the verge of death. Have you ever been interested in the biggest blasts in the universe? Every day we see the sun, and we all know that it is a strong object that sends out a lot of energy into space. But not long ago, the James Webb Space Telescope found Betelgeuse, a star that is even more beautiful than the sun. Isn't that crazy? If you want to learn more about Betelgeuse, watch this whole video to find out everything you need to know about this strange object in space. Let's start. The red supergiant star Betelgeuse is so big that it dwarfs almost all the other stars in the sky. Scientists are interested in it because of its size, strange behavior, and uneven pulses. Astronomers studied this amazing star with the James Webb Telescope and found something unexpected that could change what we know about the universe. During the winter, people in the northern hemisphere can see Betelgeuse in the sky at night. It is easy to spot because it is the bright orange-red star in the top left corner of the constellation Orion. It changes brightness over time. Even though it's one of the biggest and brightest stars, what's going on is even stranger. When it seems darker than normal, it may look like Betelgeuse is just another star to us, but it is more than 640 light-years away. Just to give you an idea, it would take more than 640 years to get to Betelgeuse if we could move at the speed of light, which we can't. Our fastest spaceship would need more than 12 million years to make the trip. Astronomers are interested in Betelgeuse because it is so far away and so big. Scientists are constantly amazed by its huge power and potential, which has helped them make important discoveries. The James Webb Telescope could change how we think about stars and the universe as a whole. When a light source moves farther away from Earth, it doesn't flash or change in brightness. But Betelgeuse, the red supergiant, does. The brightness of this very large star changes as it grows and shrinks. These changes in brightness can happen over a few days or even several hundred days, so Betelgeuse's light is hard to estimate. Betelgeuse's light can range a lot for a star, from about 0.5 magnitude to as high as 1.5 magnitude. The brightness change cycle can last between 185 and 235 days, with the smallest cycle lasting about 185 days. Betelgeuse can get very dim at times. In February 2021, when it was around 1.64, its size was one of the smallest in recent memory. You could still see it in the sky at night, but it wasn't as bright as normal. In addition to being very bright, Betelgeuse is known for having a very bright red color. Its color comes from the fact that its surface temperature is 3,500 Kelvin, which is much lower than the Sun's 5,500 Kelvin. Even though it is one of the brightest stars, it gives off less energy per unit of surface area because it is cooler. Betelgeuse, on the other hand, is an interesting star because its light and size are always changing. Think of Betelgeuse as a huge star that stands out without trying too hard. It weighs about 20 times as much as our Sun. Betelgeuse has been a bright star in the sky for a long time. It's called the armpit of Orion in Arabic, which is what the Greek astronomer Ptolemy called it back then. Not much was known about this star, but now that more advanced telescopes have been made, scientists can look at Betelgeuse in great detail. By studying the light Betelgeuse gives off, scientists have learned a lot about it, such as its size, makeup, and temperature. The Hubble Space Telescope has even taken clear pictures of Betelgeuse's surface, which show complex patterns of gas and dust. Scientists can use these pictures to make models of the star's behavior and guess how it will change in the future. Huge gas clouds coming up from the star's surface have been one of the most exciting discoveries. The pulsations of Betelgeuse are probably where these gas clouds come from, which could explain why the star changes shape. Inside Betelgeuse, a process called convection causes warmer gas to rise and cooler gas to fall. Because of the waves this motion makes, the star's atmosphere grows and shrinks. This process of expanding and contracting is what makes Betelgeuse so bright. It's interesting that Betelgeuse is thought to have a magnetic field that is 1,000 times stronger than the Sun's. This very strong magnetic field has more effects on the star's behavior and helps make it unique. Because of this magnetic action, the surface of Betelgeuse is very interesting. Star spots are places with very strong magnetic activity, and this is because the magnetic field traps gas in loops or arcs. These dark spots can be seen on both Betelgeuse and our own Sun. However, the spots on Betelgeuse are bigger and appear more often. These spots can make up to 20% of Betelgeuse's surface, and some of them can be many times bigger than Earth. Because star spots are cooler than the gas around them, they give off less light, which lowers the brightness of the star. These spots move in and out of view as Betelgeuse spins, which changes how bright it is. The star's pulsations also make changes, which makes Betelgeuse a beautiful sight to see in the sky all the time. Betelgeuse is not the only star with such a wide range of features. The brightness of other stars, like Antares in the constellation Scorpius, changes over time as well. Antares is a bright supergiant star about 700 times the diameter of the Sun. It has a mass about 12 times that of the Sun. Another star like this is Mu Cephei, which is in the constellation Cepheus and is called the Garnet Star. Mu Cephei is one of the biggest stars we know of, with a diameter almost 1,500 times that of the Sun. Antares and Mu Cephei are both variable stars, which means their light changes over time. Even though these red supergiants are alike, they are all different in their own ways. Antares is about 700 times bigger than the Sun, Betelgeuse is more than 1,000 times bigger, and Mu Cephei is even bigger with a diameter about 1,500 times that of the Sun. Their different perceived magnitudes also make them look different at night. Betelgeuse is one of the brightest stars that you can see with the human eye. Its apparent magnitude ranges from 0 to 1.3. Knowing more about these stars helps us learn more about the universe as a whole. The unique traits and actions of each star reveal important things about how stars move and change over time. Astronomers can learn more about how huge stars work and how long they last by studying stars like Betelgeuse, Antares, and Mu Cephei. Like Betelgeuse, Antares shines brightly and can be seen in the night sky in the constellation Scorpius. Its brightness changes, making it look a little brighter or darker at times, which reminds us of how the world is always changing. On the other hand, Mu Cephei, also known as the Garnet Star, is one of the brightest stars in the sky. Its brightness ranges from 3.4 to 5.1. The mass of these stars varies along with their light. Antares is about 12 times the Sun's mass, and Betelgeuse is about 11 times larger, so their sizes and brightness are about the same. Mu Cephei, on the other hand, is much heavier, with a mass thought to be almost 20 times that of the Sun. Every star has its own unique traits and habits. It is well known that Betelgeuse's pulsations make it gradually get brighter and darker. Antares, on the other hand, can look less bright because it is surrounded by a huge cloud of gas and dust that can block its light and make it look less bright than it really is. Mu Cephei is one of the brightest stars that can be seen with the human eye and is famous for how bright it is. Based on their pulsations, color changes, and general traits, these stars are getting close to the end of their lives. A supernova, which is a huge explosion that means a star has died, could happen soon for these supergiants. At first, the idea of an explosion might seem amazing, but when you learn what it really is, you see a scarier truth. Supernovae are some of the most powerful events in the universe, and for a short time, they can shine brighter than whole galaxies. Betelgeuse, Antares, and Mu Cephei are all red supergiants, but they are all different in interesting ways that make them fascinating to study. By looking at how their mass, brightness, and behavior change over time, we can learn a lot about how huge stars live and die. Astronomers are still looking at these stars for signs of the end of the world. This makes their study both interesting and important, especially since it's possible that they will die in beautiful supernovae. Supernovae are some of the most powerful and explosive events in the universe because they give off huge amounts of energy. There are two main types of supernovae, Type 1 and Type 2. Type 1 supernovae happen when a white dwarf, which is the dense leftover matter of a low-mass star, absorbs matter from a companion star until it hits a critical mass. This causes nuclear fusion to go off the rails, which blows up the star. This blast is terrible, but it's not as strong as a Type 2 supernova. When a big star runs out of nuclear fuel, it collapses in on itself and bursts because it doesn't have enough energy to fight gravity. A huge amount of energy is released in the form of heat, radiation, and light. These blasts can be so bright for a short time that they shine brighter than their own galaxy. However, the light only lasts for a few weeks or months. During the blast, everything in the area is destroyed. The burst of a supernova starts a process called nucleosynthesis, which makes heavy elements like iron, nickel, and gold. The extreme heat and pressure of the explosion create these elements. They are then sent into space, where they help form new planets and stars. Supernovae are an important part of the cosmic cycle of birth and death because when one star dies, it makes room for other heavenly bodies to form. There are two kinds of supernovae. Both are very powerful, but type 2 supernovae are bigger and have bigger effects. These cosmic events are necessary to put elements together and build new solar systems. Supernovae are an important part of the universe's process of constant change. A supernova is a very complicated way for a star to die. It also makes room for new stars to grow. When a supernova happens, it sends out shock waves that can compress gas and dust clouds around it. This can cause new solar systems and stars to form. The fact that the death of one star leads to the birth of several others shows that the world is always changing. Not only do supernovae help make stars, but they also help us learn more about the universe. Cosmology uses supernovae as standard candles to figure out how far away things are in the universe. Scientists can figure out how far away type Ia supernovae are from their home galaxies by measuring how bright they are at their brightest point. This method has been very helpful in measuring the universe's growth and finding dark energy. A supernova is a beautiful sight to see because it sends a huge amount of gas and dust into space, which can create a nebula with many colors and complicated patterns. These nebulae look different depending on the type of supernova and the material between the stars that is around it. The Crab Nebula, which is the remains of a supernova explosion first seen in 1054 AD, is one of the most studied things in the sky. Even though they are beautiful, supernovae are very dangerous. Radiation with a lot of energy, especially gamma rays, is one of their biggest threats. Gamma radiation from a supernova can be thousands of times stronger than all the energy our sun will make in its whole life. Radiation like this can kill DNA and other important biological chemicals, which are the building blocks of life. A supernova explosion can also send a shock wave hurling through space, killing everything in its way and pressing down on clouds of gas and dust to make new stars and planets. These strong forces draw attention to the fact that the world is both creative and destructive. A star like Mu Cephei, Antares, or Betelgeuse could explode with a huge amount of force in a supernova. A supernova close to Earth, especially from a star like Betelgeuse, makes a lot of people worry about what could happen to Earth if it happened. It's not likely that a Betelgeuse supernova will hit Earth directly, but if it does, the effects could be big and far-reaching. Different people have different ideas about when Betelgeuse might erupt in a supernova. Some experts think it might happen soon, while others think it might not happen for thousands of years. People think that the supernova might be happening sooner than they thought because Betelgeuse has been getting less bright lately. This lack of clarity makes it even more important to understand how stars work and what dangers cosmic events might pose. What would happen after a close supernova would not be small. A blast like this could send out a shock wave that could change the Earth's atmosphere, weather trends, and even life itself. A supernova blast could also cause changes in the Earth's magnetic field and make the ozone layer less stable. These are just the first effects that could happen. Ecosystems, land life, and the environment as a whole could be affected by these effects for a long time. While Earth appears to be safe from Betelgeuse for now, we can't be sure that nothing bad will happen because of how chaotic and uncertain cosmic events are. Scientists can now study stellar events with amazing accuracy, thanks to better telescopes and observational methods. This gives them useful information about how stars behave and change over time. More knowledge about supernovae and their possible effects will help us be more prepared for the dangers these stellar events pose. Finally, the fact that a Betelgeuse supernova is possible is a sobering warning of how dynamic and always changing the universe is. The potential death of a star like Betelgeuse offers an intriguing perspective on the life cycle of massive stars. As it nears the end of its life, Betelgeuse will likely undergo a dramatic transformation, culminating in a supernova. This explosive event is not only a spectacular cosmic spectacle but also a crucial process for the creation of heavier elements necessary for life as we know it. One of the most captivating aspects of a star's final stages is how the surrounding space is affected by the massive explosion. As a star runs out of nuclear fuel, the core contracts, causing the outer layers to expand dramatically. In the case of Betelgeuse, this process could potentially lead to a massive shockwave that will travel through space, carrying with it vast amounts of energy, gas, and dust. These materials, expelled during the supernova, will enrich the interstellar medium, providing the building blocks for the formation of new stars, planets, and even life in distant regions of the universe. Additionally, these supernova remnants, in the form of nebulae, are often seen as some of the most visually stunning objects in the cosmos. The Crab Nebula, a result of a supernova observed in 1054 AD, has been studied for centuries, revealing fascinating insights into the aftermath of such explosive events. The gas and dust ejected from the supernova can create intricate, colorful structures that change over time as the particles mix with other elements in space. Such stellar events also raise questions about the role of these cosmic forces in shaping the universe's evolution. They challenge our understanding of time, space, and the fundamental forces of nature. Even though the chances of a supernova from Betelgeuse directly affecting Earth are minimal, the study of these cosmic phenomena provides vital knowledge about how the universe operates on grand scales, offering insights into the past and future of stars across the galaxy. Understanding the behavior of red supergiants like Betelgeuse helps astronomers predict the fate of similar stars and even estimate the potential for life in other solar systems.